In an earlier tutorial, we found the initial basic feasible solution of this problem using the four-jaws approximation method. So we found that it is these allocations. In this video, I'm going to find the optimal solution using the modified distribution method. So for the modified distribution method, we start by calculating the dual variables. So we'll be looking at each occupied cell, and the formula that we use is Cij is equals to Ui plus Vj. So what we would have is for each row, we would have a U. So we would have a U1, a U2, a U3, and then for the columns V1, V2, V3, and V4. To start with, we set one of the u's to be equals to 0, but it is convenient to take the u or v, which we set to be equals to 0, to be in a column or row which has the most number of allocations. So in this case, we see that this row here has the most number of allocations, so we set that u there to be equals to 0, so def u2 there is equals to 0. So when you set u2 equals to 0, then we go on and use our formula here so that we obtain the v's. So when you are looking at this part here, it will be 24 is equals to the 0 plus the v1 here. So we will have that v1 is equals to 24 minus 0, which will give us a 24. And then we go on to this part here, the 9. It will be saying 9 is equals to 0 plus v3. So we'll be having that v3 is equals to 9 minus 0, which gives us a 9. And then go on to this part here, it will be saying 7 is equals to 0 plus v4, which will give us v4, 7 minus 0, which will give us a 7. And then we go on to the next one. We look at this one here. So the 32 will be equals to the u3 plus the v1, of which v1 we are saying is 24. So the u3 there will be equals to 32 minus 24, which will give us an 8. And then we go to the next part. We can look at this one now, the 4. For the 4, we are saying it will be u1 plus this v4. So we would obtain that our u1 there will be equals to 4 minus 7, and that will give us a minus 3. And then we go on and look at this part here. We now have a 22. So we'll be saying 22 is equals to minus 3, then plus the v2. So the v2 there will be equals to 22, then plus 3, which will give us a 25. So we now have our dual variables. We go on and calculate the opportunity cost for the unoccupied cells. So the formula that we use is Dij is equals to Cij minus Ui plus Vj. And the Cij is the unit cost, and the U and the V are the ones that we have just calculated here. So I go on and draw a table where we have the cell and the value of the Dij. So we start by looking at this cell here. That's cell F1 to A. For cell F1 to A, what we'll be saying there is the cost, the 20, and then minus the sum of these two values. And that will give us 20 minus minus 3 plus 24, which will give us a minus 1. Then go on to the next unoccupied cell, this one here. We are looking at cell F1 to C. For cell F1 to C, we'll be saying 17, then minus the sum of these two values. So it will be 17 minus minus 3 plus 9, and that will give us an 11. Then we go on to the next unoccupied cell, this one here. We are looking at F2 to B. For F2 to B, we'll be saying 37, then minus the sum of these two values, and that will be 37 minus 0 plus 25, which will give us a 12. And then the next unoccupied cell, we are looking at this one here. That's a cell F3 to B. For cell F3 to B, we'll be saying 37 minus the sum of these two values. So we'll be having 37 minus 8 plus 25, which will give us a 4. And then go on to the next unoccupied cell, this one here. We are saying F3 to C. For F3 to C, it will be 20 minus the sum of these two values. So it will be 20 minus 8 plus 9, which will give us a 3. And then lastly, we are looking at this cell here. That's cell F3 to D. We are looking at the 15, then minus the sum of these two values, and it will give us 15 minus 8 plus 7, and that will give us a 0. Our solution is optimal if the opportunity costs are greater than or equals to 0. But in this case, we see that this cost here is negative, is less than 0. So the solution there is not optimal. So if the solution is not optimal, then we go on to the next step. And that is we allocate as much as possible to the cell that had the negative opportunity cost, which is this cell here, cell F1A. So starting at that cell, we draw a closed path, then put alternating plus or minus signs, and we'll be putting those plus or minus signs on occupied cells. So starting on this cell, we put a plus. Then we move to a cell which is occupied. Then we go on and put a minus. So our path should bring us back to this highlighted cell. So I'll put a minus here. So on this part here, on the D there, that's where I'll go on and put a minus. And then when you put a minus there, we move on to another occupied cell. Then we go on and put a plus. So we'll move to this occupied cell, then put a plus there. And then lastly, we go on and look at a cell which is occupied, which leads us back to the cell that I highlighted in red there. So that cell is the one which is the 10 there. So that's the cell that we go to, and we now put a minus. So it's plus, minus alternating. Then we are saying it forms a closed path going back to the unoccupied cell that we have chosen. So the next step now is to go on and see how much we can allocate. To see how much we can allocate, we look at the cells that have the minus signs. The cells that have the minus signs are these ones here. We have an 80 here, it is a minus. Then a 10 here, it is a minus. So we take the minimum of those two values. The minimum of those two values is a 10. So we are looking at the minimum we are saying is 10. So for that 10, we go on and add it to all the cells that have a positive and subtract it from all the cells that have a negative. So we are looking at that 10 here. So we look at this cell here, it is a plus there. So we add the 10. So when you add the 10, we would have 10 units there. And this cell here had 30 units, but it is having a plus. So we are adding the 10. And when you add the 10, so the 30 goes away, so that it will be 30 plus 10, then we would have 40 now. Then for the cells that have the negatives, we subtracted that 10 that we have talked about. So we subtract 10 here, and we remain with nothing, so the 10 goes away. And here we subtract the 10, and the 80 goes, so we remain with 70. So those are the allocations that we have now. But before proceeding, you should just check if your allocations are matching the supply and the demand. In this case, we see that they are matching the supply and the demand there of 120, 70, 50, 60, 40, 30, 110. So our allocations are balanced there. And then we go on to the next step. We repeat the step of calculating the dual variables, the UI and VJ for each occupied cell. So we go on and use our formula, the one that we used before. Cij is equals to UI plus Vj. So we need for each row, we would have a U. So we have a U1, a U2, a U3. For each column, we would have a V. So we have V1, V2, V3, and V4. It is convenient to take the row or column with the most allocations. That's the one where we set the U or the V to be equals to 0. In this case, we see that this row here has 3 allocations, and that's the most there. So we choose our U1 there to be equals to 0. So I'll write my U1 equals to 0. Then we go on and use this U1 to find the V1, the V2, and the V4. So to find V1, we look at this 20 here. So using our formula, we are saying 20 is equals to the 0 plus the V1. So V1 will be equals to 20 minus 0, which gives us a 20. And then for V2, we are looking at this 22. We are saying it is equals to 0 plus V2. So V2 will be equals to 22 minus 0, which gives us a 22. And then for the V4 there, we are looking at this 4. We are saying it is equals to 0 plus V4. So V4 will be equals to 4 minus 0, which gives us a 4. And then we go on and look at this 7 here, 7 will be saying it is equals to U2 plus this V4. So our U2 there will be equals to 7 minus 4, which gives us a 3. Then we go on to the next step there. We can look at this 9. For this 9, we will be saying 9 is equals to 3 plus V3. And that will give us our V3 is equals to 9 minus 3, which will give us a 6. And then lastly, we look at this part here. We are saying 32 is equals to U3 plus 20. So our U3 there will be equals to 32 minus 20, which will give us a 12. So we have obtained our dual variables. Then we go on and calculate the opportunity cost for each unoccupied cell. And the formula that we use is Dij is equals to Cij minus Ui plus Vj. So I'll go on and draw a table where we have the cell and the Dij. So the unoccupied cell that we'll first look at is this one here. So that's F1 to C. So for F1 to C there, what we'll be saying is the 17 minus the sum of these two values, which will give us 17 minus 0 plus 6, which is an 11. Then we go on to the next unoccupied cell, this one here. That's cell F2 to A. So for cell F2 to A, we'll be having 24 minus the sum of this 3 and this 20. So we'll be having 24 minus 3 plus 20, and that will give us a 1. Now the next unoccupied cell, this one here, we are looking at cell F2 to B. So for cell F2 to B, we'll be saying the cost 37, then minus the sum of these two values, and that will be 37 minus 3 plus 22, which will give us a 12. The next unoccupied cell is this one here. We are talking about cell F3 to B. So for cell F3 to B, we will be saying 37 minus the sum of these two values, and that will give us 37 minus 12 plus 22, which will give us a 3. Then the next unoccupied cell is this one here, cell F3 to C. So for cell F3 to C, we'll be saying 20 minus the sum of these two values, 12 plus 6. So it will be 20 minus 12 plus 6, which will give us a 2. Then lastly, we are looking at this unoccupied cell. So what we'll be looking at there is cell F3 to D. So for this cell, we are saying 15 minus the sum of these two values. So we'll be having 15 minus 12 plus 4, and that will give us a minus 1. Our solution is optimal if the opportunity costs are greater than or equals to 0. In this case, we are having this opportunity cost is negative. So the solution there is not optimal. So if it is not optimal, then we have to allocate as much as possible to the cell with that negative value. So the cell with that negative value is cell F3D. So what we are saying is we are looking at cell F3D here, this one. Then we go on and draw a closed path starting at this cell. So we'll put a positive. So for our closed path, it will be passing through occupied cells. So for the occupied cells, I can move to this cell here. Then we put a negative. And then go on and look at this cell here. And then lastly, we try to look at an occupied cell which links us to the cell that we came from originally. We are only allowed to move horizontally or vertically. So that cell there is the one with the 70 there, and we are going to put a negative. Then it allows us to go back to our original cell. So the path is now closed. So we then go on and look at how much we can allocate. So for how much we can allocate, we look at the cells that have the negative signs. So the cells with the minus signs, we are having this one here with the 70 and this one here with the 50. So we take the minimum of the 70 at 50. That minimum there is at 50. So we are supposed to allocate 50 units in the cell that I have highlighted there. So in this cell, we go on and allocate 50 units. But we also add that 50 units to the cells that have a plus. So the other cell that has a plus is this one here. So we add the 50 there. So the 10 plus 50 to give us a 60. So we remove the 10, then now put a 60. Then on the cells that have the negative signs, we go on and subtract the 50. So we subtract 50 here, we get a 0, so this goes away. Then here we subtract 50, then we remain with 20. So that will be the allocation there, 20 units. So when you have done our allocations, then you just check if the allocations there are balancing with the supply and the demand. So we can see that the first row there is giving us a 120, and the second row 70, the third row 50. Then the first column 60, the second column 40, third column 30, then column D there is adding up to 110. So our allocations are okay there. Then we go on to the next step. So for the next step, we are calculating again our dual variables. So for our dual variables, we use our formula Cij is equals to Ui plus Vj. So for each row, we have a U1, a U2, a U3. Then for the columns, we have the V's. So we have V1, a V2, a V3, and a V4. Then we go on and choose one of the U or V to be equals to 0. So we choose the row or column which has the most number of allocations. So in this case, we see that the first row there has 3 allocations. So go on and choose that U1 to be equals to 0. So I'll go on and write that my U1 there is equals to 0. So using that U1, we can now find the V's. So what we'll be saying, if we look at this 20 here, we'll be saying 20 is equals to 0 plus V1. So whatever V1 is equals to 20 minus 0, which gives us a 20. And then we go on to this one here, 22. We are saying 22 is equals to 0 plus V2. So V2 is equals to 22 minus 0, which gives us a 22. Then we go on and look at this 4 here. We are saying 4 is equals to 0 plus V4. So V4 is equals to 4 minus 0, which gives us a 4. And then we go on and look at this 7. 7, we are saying it is equals to U2 plus V4. So we'll be having U2 there is equals to 7 minus 4, which gives us a 3. And then we go on to the next one. We look at this 15. 15, we are saying it is equals to U3 plus V4. So def U3 is equals to 15 minus 4, which gives us an 11. And then lastly, we look at this part here, the 9. For the 9, we'll be saying it is equals to the 3 plus V3. So V3 will be equals to 9 minus 3, which gives us a 6. So we have obtained our dual variables. We go on to the next step of calculating the opportunity cost for unoccupied cells. And the formula that we use there is Dij is equals to Cij minus Ui plus Vj. So we go on and draw a table where we have the cell and the Dij. So we are looking at unoccupied cells. So we start with this one here. So that's cell F1 to C. So for cell F1 to C, we'll be saying 17 minus the sum of these two values, and that will give us 17 minus 0 plus 6, and that is an 11. And then the next unoccupied cell is this one here. We are looking at cell F2 to A. So for cell F2 to A, we are saying 24 minus the sum of these two values, and that is 24 minus 3 plus 20, and that gives us a 1. Then the next unoccupied cell is this one here. That is cell F2 to B. So for cell F2 to B, we are looking at 37 minus the sum of these two. So we'll be saying 37 minus 3 plus 22, and that will give us a 12. And the next unoccupied cell is this one here. That is cell F3 to A. For cell F3 to A, we are looking at 32 minus the sum of these two values, and that will give us 32 minus 11 plus 20, which is equals to a 1. The next unoccupied cell is this one here. That is cell F3 to B. So for cell F3 to B, we are saying 37 minus the sum of these two values, and that will give us 37 minus 11 plus 22, which gives us a 4. And then lastly, we are looking at this cell here. That's cell F3 to C. So for cell F3 to C, we are saying 20 minus the sum of these two values. So that gives us 20 minus 11 plus 6. And the value that we get there is 3. So what we are having there is all the opportunity costs are greater than or equal to 0. If all the opportunity costs are greater than or equal to 0, then we have found the optimal solution. So our solution is now optimal. Then we go on to interpret what we are having there. So I will draw a table with the destination, allocation, and the cost. So we start by looking at this one here. That's F1 to A. For F1 to A, we are allocating 60 units. 60 units at a unit cost of 20. So the total cost there will be 60 times 20, which gives us a 1,200. Then we go on to the next one. This one here, we are looking at cell F1 to B. We are allocating 40 units. 40 units at a unit cost of 22. The cost will be 40 times 22, and that will give us an 880. Then we go on to the next one. This one here, we are saying F1 to D. We are allocating 20 units. 20 units at a unit cost of 4. So the cost there will be 20 times 4, which gives us an 80. Then we go on to the next allocation there is this one here. We are looking at F2 to C. F2 to C, we are allocating 30 units. 30 units at a unit cost of 9, and that will give us a cost 30 times 9, which will give us 270. Then we go on to the next one. This one here, we are looking at cell F2 to D. F2 to D, we are allocating 40 units. 40 units at a unit cost of 7, so the cost there will be 40 times 7, and that gives us 280. And lastly, we are looking at this allocation here. That's F3 to D. F3 to D, we are allocating 50 units. 50 units at a unit cost of 15. The cost will be 50 times 15, and that will give us a 750. And for the cost for all the allocations, we add these values, and we have the total cost there is 3,460. So we are having the optimal solution. Yes, these allocations shown on the left, and the total cost is 3,460. So that's our optimal solution there.